Hi everyone, today we'll be looking at question number 3834, merge adjacent equal elements. In this question, we are given an array of integers called nums and we need to check if two adjacent elements are equal. If they are, we need to choose the leftmost such adjacent pair and replace them with a single element which equals to the sum. Now, this line may confuse a lot of people. Leftmost such adjacent pair. This means in our array, if we have something like 333, then we need to choose the leftmost pair and this will result in something like 6, 3. After each merge operation, the array size decreases by 1. We need to repeat this process until there are no more changes. Means no adjacent equal elements remain in our array. And we return back the final array. In short, checking for two adjacent elements, if we find them equal, merging them into their sum. Having a look at the given example, for the first example we have an array which contains 3, 1, 1 and 2. So we start iterating from the left, we come across 1 and 1 which results back in 2. We again start scanning an array, find a pair of 2 and 2, and merge it, resulting in 4. Since there are no more adjacent equal pairs, we return back our output. For the next example, we have 2, 2, 4. We start scanning, we come across 2, 2, the sum resulting in 4. We start scanning again, we come across 4, 4, which becomes 8, and thus we return back 8. For the third example, 3, 7 and 5, there are no adjacent equal elements in the array and hence we return back as it is. Now the brute force or the straightforward approach that comes to us is scan the array, merge the pair we find, then start scanning again and do this until the last scan has no merges. But this leads to a time complexity of O(n) square, which can cause time limit exceeded on large inputs. So we need a faster approach. So for that, instead of rescanning again and again, we use a stack-like structure. So the idea is to have a stack of elements. We start iterating through our array and until we find a common pair, we start pushing the elements onto the stack. Once we come across a current number which matches with the top of the number on the stack, we remove the top, we double the current value and then check again at the top of the stack for if the new value matches or not. We do this using a while loop. This approach requires traversing through the array only once and hence reduces the time complexity to O of n. Suppose we have an example of array 1, 2, 2, 4, 4 and 8. Our stack is initially empty. We start iterating from the leftmost, we come across the first. The stack is empty, we push 1 onto it. Then the next element 2, since the top of the stack does not match the current element, we push 2 to it onto the stack. We iterate further, our current element now being 2 again. Since the top of the stack matches with the current element, we pop the top of the stack and update our current to the sum. 2 plus 2 makes a 4. We check to the top of the stack if 4 matches 1. Since it does not, we push back 4, thus merging this pair. We update our current to the next value. Since it matches the top of the stack, we pop the top and update our current to the sum of value. 4 plus 4 makes 8. Since 8 does not match to the value on the top of the stack, we push the current value to the stack and update our iterator to the next. The current now points to 4, and since the top of the stack is 8 which does not match with 4, we again push the current value. We iterate further, the current becomes 8, and since the top of the stack contains 4 which does not match, we return back 8. Thus, this is our final array 1, 8, 4, 8. Let's have a look at the code. We create a stack. Then we create a for loop to iterate over our nums. We take each element from the array one by one and store it in the variable num. Our current points to that variable. While the stack is not empty and the last element, or basically the topmost element, is equal to our current, we pop the last element and store the sum in the current. Using while loop, we ensure that this is done up till the stack is empty or up till the value does not match the current. Once we ensure that the value doesn't match the current, we add it to our stack. At the end, we return our stack in the form of an array list as it was asked in the question. One thing to keep in mind here is mostly for stack operations we use push and pop, but those work from the front of the D queue, which reverses the order and results in wrong answer. The correct approach is using peek last, poll last and add last. In case we are using push and pop, we would need to reverse the array list we are returning at the end. This approach has a time complexity of O(n) as each element is pushed once and popped at most once. The space complexity is O(n) as the stack would at most be of the length of the array. I hope I was able to explain the solution clearly. For any suggestions or doubts, comment down. Thank you.